with title Seismic Microzonation based on Micro-tremor result. And then I'm Rusnardi. I'm head of Research Center for Research of Negeri Padang, lecturer, and also now I'm director of International Office Universitas Negeri Padang. And then I would like a little bit briefly inform about myself, as informed by Professor Hayati about me. So this is the first photos when I was in Kyoto University, and then this is my lovely mom. She always support me, and then we love her very much. And then the third photo when I was graduating, and then this is the Kyoto University president, and then this is my wife. My wife also got PhD from Kyoto University in medicine department. And then in this photos when I was in Canada, we conducted research on liquefaction there. This is Ottawa sand. So before I never seen the Ottawa sand, so now I can see clearly, and then I can touch the Ottawa sand. And then this picture, my rector and me, when I was got the best achievement in research, and 2 times. The first in 2014 and second one 2015. So this is my background of my research. As we know, Indonesia has 3 plates surrounding Indonesia island. We know the Indonesian plate is very stable, and then there are 3 plates surrounding, and at the western side, Indo-Australian plate, subduct our Indonesia started plate. The slip rate is around 7 to 8 centimeter per year. And the eastern side also Pacific plate and Filipino plate also subduct the Indonesian plate. And then we can see the black circle is Padang, when I'm living now here. Padang State University is here too. And then this is a from 1779 to 2020 with man completed and full. And then we can see that clearly the red color and yellow and green color is the epicenter depth. And then when we see this figure, we can see clearly about the most earthquake occurred in Indonesia is the shallow depth. So that means the depth is between 3 to 200, between 3 to 100 kilometer depth. And then the prone area of Indonesia, almost all region in Indonesia are prone area. So it means the earthquake can occur in Indonesia anytime, and then we cannot predict very well when the exact time of the earthquake occur in Indonesia. And then I would like to inform that so the earthquake during 10 years, we know Aceh earthquake. This more than 10 years, but I just to show our memories, the earthquake occurred in Aceh before December 2004. The source mechanism is plate and Yogyakarta, Tasikmalaya, and Padang, Kerinci, Mentawai, and Mataram. And then the latest one is a Palu earthquake. And we know clearly Palu earthquake produced tsunami and then killed many people there. More than 2,000 people killed by earthquake and tsunami. And then Padang, this is Sumatra Island, when we are living now. As I informed before, the red color is the earthquake depth, and the earthquake depth is very shallow. And then this is I cropped this area. We can see this the earthquake occurring here. More than 4,000 earthquakes occurred from this year to this year. And then this is shows the current earthquake, 5 years, 5 year previous earthquake occurred in here. And then I would like to inform number of the earthquake occurred in Indonesia in 1 year, more than 1,200 earthquakes with magnitude greater than 4. This way, I can say this number because I got data from 3 years or 4 years, 400 years ago, and then we clusterate and classify all the data. So we can say number of the earthquake occurred in Indonesia is around 1,200 events in 1 year. And then this is the Padang earthquake. This is one reason why we conduct seismic microzonation in Indonesia. This is Padang earthquake. Padang earthquake, this is a ground motion. I got this data from the SPAC Method. We installed it in Andalas University, and then the right side is the response spectra. We convert it to response spectra. This is our standard Indonesian standard design, and then this is a currently. I mean, we used the standard until 2012, and then the earthquake occurred in 2009. So we can see how big the ground acceleration compare with our standard. So when we look at this picture, maybe this 0.4. So the earthquake with stories less than 4 has potential damage due to this earthquake. And then objective of the outline of study, one, the investigation of ground profile in Padang City, Indonesia. So from investigation of ground profile, we can determine the soil characteristic, and then we can determine the natural period of ground at the surface, because we are staying at the surface. So it means the response of at the surface is very important. We know very important to know because we designed the building at the surface. And the second one is seismic response analysis of horizontal land deposit capacity damage analysis. And then 4 is seismic analysis for seismic design in Indonesia. But in this presentation, I will focus on investigation of ground profile in Padang City. Maybe next time when we have time, we can share again how to make seismic analysis and how to analyze the seismic response. And then we know the amplification at the surface anywhere when we calculate the or obtain it ground motion. And then here they are the outline. One is investigation of ground profile in Padang City. Briefly explain the Padang earthquake. I will inform the audience about Padang earthquake, and then currently in Padang no ground profile exists up to now. And then so how we solve the problem? One is we did micro-tremor observation. Micro-tremor observation divide 2 types. One is single observation, array observation, and then the additional one I will compare with questionnaire survey observation. And then, as I informed in the ground, this introduction, this is seismicity of Sumatra, magnitude greater than 4. And then the B seismic of Sumatra Island from 2005 to 2000. And then about Padang City with population 956,801. And then people, this is data I got from Padang local government. This data is for 2020. The capital of West Sumatra And then what's the location of the center? You can check this one by Google Map, the location. And then the main part of Padang is situated on alluvial plain between Indian Ocean and the mountain. You can see clearly from here. This is a mountain side. Padang City is from here to here. It's Padang City. And then the topography of Padang region is similar to the tsunami damage area of Miyagi Prefecture in Padang, in Japan, that inundated by as much as 4 to 5 kilometers from the coast after the March 11, 2011 of the Pacific coast of the earthquake. So many scientists predicted when the earthquake occurred in the western side, subduction side, the tsunami inundation can reach inland around 4 to 5 kilometers because Padang City elevation is very flat, so not like very high like this, but very flat. So when we are in this area, so the elevation is less than sea level. So sea level, for example, 0, and here is here around -2 meters. And then this is population distribution in Padang. As we know, Padang density is very high, 9,500 people kilometer per square. So we can imagine when the earthquake occur. So when we do evacuation together, so we can find conjunction and we can find crowded anywhere, and then very easy the tsunami reach our location. So now government prepare several shelter practical evacuation in Padang. Now there are 60 or 65 shelters are ready to use. And then damage from 2000 Padang earthquake. So Padang City, Padang City cover an area about 695 kilometers square, divided into 11 districts. And this is on the western side, this is the sea. This is the biggest, the most wide area of the Tanah. And I believe some of lecturers from UiTM have been to Padang before. So maybe if we get a question about Padang, the audience can ask the lecturer from UiTM, because we have good collaboration with this university, Padang State University, Universitas Padang, and UiTM. Now we have MOU, and then in the future we will invite them to. And then this is a damage from 2000 Padang earthquake. This is the ground motion we record, as I informed before. We record from Andalas University, and then we convert this one. We change from time domain to frequency domain, so we can see the peak of this earthquake is 0.5 seconds. So this means that the predominant period of this ground motion is 0.5. The observed record show about 2 seconds strong shaking from here to here, we assume, and then from this figures, with peak ground acceleration of 0.35 g. So when we convert to GAL is 380 GAL, and which with predominant period is 0.5 seconds. And then this is damage houses and damage ratio. This is severe damage, moderate damage, slight damage. And then we can see number of severe damage is very high, 33,597, and then moderate, and then total is more than 100,000 building damage to this earthquake. And then to the building also, the building mean is like the building use it for office, for example, more than 2 stories building. So we call here a building. So 200, 2,000, 1,000, and slide is 1,000. When we calculate this, it's around 4,000 building damage due to this earthquake. And then you see the infrastructure in each district. Road number damage road is 8, moderate damage 22, and then bridges and several damage 8. Yeah. So 8 means the bridges cannot be used temporarily during after the earthquake around 20 days. And then slight damage and severe damage of the bridges. And then for observation, we use some we use the micro-tremor devices. So we conduct 6 times. So when I was PhD student, and then we joined with master student, and then last month we conducted again the micro-tremor observation. We develop our research to liquefaction. So we propose frequency to determine the liquefaction. So from there, this is very important result. And then devices we use GPL, CA, 3P, Akasi cooperation with 3 direction sensor, X, Y, and Z. Duration time is 10 minutes, sampling frequency 200. So we very careful because we have to omit the noise. So we consider the location. I mean, when we put one location, we consider the situation when we record the data. First, single observation. As we know, micro-tremor is very small ground motion that can be recorded on the ground surface. It can produce a very deep excitation. We know the ground motion comes from the wind, traffic, breaking sea wave, and then human activity. Full micro-tremor record can be described by graphical and 2 relevant component as I informed. There are 3 directions. One is vertical and 2 horizontal, X and Y. Our analysis was conducted using a recorded micro-tremor, and then we use this equation, X over B ratio. This is north-south direction, and then we have to change from time domain to frequency domain for north-south side, and then for this one the same. We have to change time domain to frequency domain. This is up-down. We divided this one based on frequency, angular frequency. So we have to consider the same frequency. And then normal analysis for micro-tremor single observation. So we make some windows. Why we make some windows? We have to omit the noise. So when we see these figures, and then this is a same peak, we consider the same peak. The same also as the same peak, and then we omit this. We assume suddenly great amplitude or ground motion is noise. We have to omit it. So with window 1, 2, 3, and then 4, 5, 6. So normally we consider 10. This is not only 10, maybe if we want more, we can cluster it. We can make window more than 10, but in my case, we consider 10 windows. We only consider the ground motion at the same amplitude, at the same peak. And then this is XOV ratio. From one window, I would like to explain how to make XOV ratio. This is window one. So window one, so this is we can see the color, same color. For example, this one, the window one. So this is a Z and Z north. Z means is up down, and mean is north south. This means is west. Okay, and then we multiply this one, and then we divide it by Z, and then root. So please consider how we can multiply and then how we divide it. We have to consider at the same frequency. So here with same frequency we can get one, and then for the second one we can get one more line, and then for this one we can get one more line. So from here we can see clearly the peak, the maximum peak at the same frequency in here. So from here we can inform the frequency of this wave is 2.5 hertz. This is fundamental analysis for micro-tremor signal observation. And then from the result, we can divide it for when we analyze. So we have to know there are four results. For example, XOV ratio. Red line is average, and the black sum is something like XOV ratio. The peak greater than 1. So we can from here when we get the result like figure A, this is a clearly peak. So we can easily to say the peak the permanent period of this X over V is greater than 1. And then the B, there are two peaks, 1 and 2. The peak one is a response from at the surface, and the second one is response as maybe the second layer or the third layer or the backdrop one. So this is the at the surface. And then from here, so we can see clearly the peak is less than 1 second. And then this one, we cannot see any peak because when we see all peak at the same level, so we have to repeat, we have to do observation again in this side. This is a result. So we observe around 110 site in Padang city. We can see this is red circle is a location that we observe location, and then from here we plot a result of XOV ratio. So for this one we use a kriging method, spatial analysis, and then we can obtain the XOV ratio for all Padang. So what is the meaning of these figures? One is when the earthquake greater than 1 second, so it means the predominant that is a long period. A long period, so it means more dangerous for the building because the duration of the earthquake is more than 1 second. And then in Padang, most of Padang city has a predominant period greater than 1 second. So this is one good report to our government how the government will overcome this problem by making standard. I mean, all the people who want to construct the building, they have to report to government, and then government will give permit based on the quality of design. So when the design follow this code, and the government will give a permission to construct their own building. And then for evacuation SAM, this is we can use this one for seismic microzonation because we know the pregnant period of the ground, and this we can apply this one to mitigation system, and then we can apply this one to design code, and then on future design for the construction. And then for the second one is also important. So for this one is the this one for at the surface, and then for this one micro-tremor area observation is very important. We know the soil's characteristic from the bedrock to the surface. For example, we know the soil structure at the third layer, and then the second layer at the first layer. So for the micro-tremor area observation in Padang, we conducted before 12 sites at several districts in Padang. And then for micro-tremor area observation, the minimum, this is a long list, I know that we used before, number of the equipment or devices are 4. I mean, we cannot use less than 4. So here, this is central, and then this is 1, 2, and 3. This is we call this very central in calculation. We will put a code at F, and then it's G. 1, 2, 3, 4. And then this is a SPAC method, array observation, calculate power spectra, SPAC function. So from here, first is we change time domain, frequency domain, and then we can get frequency for each radius for each device, and then after that we can make average. I can explain later, and calculate the SPAC coefficient, estimate velocities. This is inversion and geological structure. This is the step of SPAC method. First is circular array for SPAC method. From here, we only consider the vertical motion only. So we do not consider X and Y. We only consider vertical motion. For example, this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 0. And then why 10? Because number of sensor is more than 4. We only consider vertical only. And then from this, and then for example, this is a relative wave velocity for one side. This is one side, and then there is one question. Maybe next time I can, if any question about this one, we can explain by a question, because when you see these figures, we need a question to explain this one. So this is from different distance, different radius. One is 50 meters. For example, this is this is for 30 meters, 10 meters, and then 3 meters. So they are 1, 2, 3, 1, 2, 3. There are 3. 3, 10, and 30. So this is this color is for 10 meters, and then the black one is the black one is for 3 meters, and then for this one for 30 meters. We plot all for it's a phase velocity. We plot all like this, and then we can draw new line as average. We can start from here, and then we make this line. Okay, and then from that line, we use inversion. This is for many sites. For many sites, there are 1, 2, 3, 4, 5. There are 5 sites. This is for 5 sites. From this this line, we move to this line. So it will become together with one site, with several sites. And then from here, we use swarm optimization, and then inversion. We can get the soil characteristic. This is the depth. Sorry, this is the depth, and then this is velocity. From the velocity, we can determine the soil characteristic when the soil velocity less than 150. We consider this ground is the soil is a soft soil, and then between 150 to 300, we consider this soil is medium, and then more than greater than 300 meter per second quadrant square is rock soil. And then this is observation that we conducted in Padang before. There are 4 sensors. This is the main sensor in the center, and then 1, 2, 3, and then this is my supervisor, Professor Dindikiano, and we conduct together in Padang, and with 2 students too. And then from this one, this was also very important. We can get the average shear velocity of the upper 3 meter of the soil. So from the result, micro-tremor result, we can determine the thickness 3 meter, and this is VS, and then this is thickness for second layer, because we consider his PS. This is the first layer, and second layer, and the third layer, and this is the fourth layer. We can see clearly in 3-dimensional. Here, from IDS here to western side, this is east side, and then the eastern side. So the soil profile like this. This is the first layer, the red color. Sorry, this is the third layer, and then for the first layer, and then the second layer, and then this is the third layer. So we can use these figures to determine we can simulate the ground motion from the bedrock to the surface by using this figure. And then this one from the north to south. This is UNP, this is our campus. This is the north side, UNP, FTB, Governor Office. This is a football in the Chinatown. So we can see this is the first layer, and then the second layer, and the third layer. So most of this area is subsoil. And then from this one, the Andalas University, BRI, and SMO are hard soil or rock soil, because the velocity greater than 300. And then this is line 1. We try to draw for each layer by consider this data. This is from east to west, and then this one from north to south. We can draw the line 1. This is line 1. So we can see this is from north to south. This is quite depth for subsoil. So it means when the earthquake occur in the future in this area, the surface will give more response to the earthquake. I mean, it means amplification of the ground motion is greater than from the side, because in this area is a subsoil. This is for the layer 2. We can see this is layer 2, and then this one is layer 3. So from micro-tremor, we can obtain the characteristic of the soil until 350 meter depth. And then we try to plot Silver's the 3 meter depth, because it's very important, because the building constructed at the surface, and then the foundation of the construction is between 2 meter to 300 to 30 meter depth. So this is PS velocity. So the red color mean soil characteristic is soft. You can see here. So it's the red color. The red color is mean the silt velocity less than 200, and then the orange one is between 200 and 400. So it means the medium soil type. So this is we can use the figures as seismic microzonation, and then we can inform this map to government for future mitigation. I discussed with research agency of Padang City before, and now I'm a member of Padang City for research agency. So we join, and then we apply this figure. And then this additional, so this is by micro-tremor, this is additional one. So by software, by Questionnaire surveying, this method was originally deployed by OTA in 1979. So this is for developing a seismic macro or micro zoning map in Japan. So in Indonesia, Mr. Honda applied this one for Aceh earthquake, for Aceh area, and then we try, and then we conduct it in Padang too. The number of questionnaires is 500, and we distributed the questionnaire, and before with the person we teach before, and then we share our knowledge on this questionnaire survey, because the original one, the questionnaire written in Japanese. So we translate it to Indonesian language. And then we distribute number of distribution, this one, for all the Padang City. And then this is Japanese, original written in Japanese. And then we translate to Indonesia. This is this one already checked by expert. Is translation is good or not? I mean, the quality of translation. And then by using this equation, and then we follow this equation. So we know the AG is E12. So some question we have to follow the procedures. So then we get the result in GMA, Japan Meteorology Agency, intensity. Is a question, the result from a question 2 instead of question 3. So there are several steps. And then this 1, 3, and 4. So if the audience want to know how to analyze, we can share in Excel file how to calculate this one. And then from here, we can get seismic intensity For example, this is number of questionnaires, 30 people, assessment intensity 4.5. And then this is Japan. We convert from assessment intensity to GMA. When the result less than 5 and greater than 4, we say that it's 5 minus. And the greater than 5, it means 5 plus. So we can see the distribution of questionnaire result, especially for 11 district, 4.7, 5.3, and then 5. So we can see the result in GMA on most of the Padang areas damage to the earthquake. So we can see, I will inform the audience correlation between Japan Meteorology Agency and Micro-tremor Observation. We can see what is the relationship. So this is very important. We know the soil characteristic, and then we know the effect the earthquake when we stay at the subsoil. So when I work to the figures, so when we from micro-tremor from here to here is subsoil, so we can see the Japan Meteorology Agency intensity is 5 plus, 5 plus, and 5 plus. So this is a good agreement between micro-tremor observation and this is Japan Meteorology Agency intensity. So this is western side, C, 5 plus, 5 plus, 5 plus. And then it's medium one is 5 minus, 5 minus. And then it's the rock side, 5 minus. But this one not totally, the building installed in some side, but the quality of building also give contribution to quality of structure. So this is, we also classify the building condition. It's a wood and bamboo, 3%, and then reinforcement is 94%, and then this is our question survey in area when VS less than 400 meter per second, and area 2 when the VS 30 less than 400 seconds. This is for area 1 and for area 2. And then this area 2, you can see the number of building age. This is 3 to 10 years, and this area. This is integrated seismic microzonation. This is from micro-tremor observation, and then this is UiTM. So we can see in this area, and then this area is near subsoil and has great potential to damage the structure. We can prove that one when the earthquake here in Padang in 2009. So when we see the red color, and then we can see here the JNA, Japan Meteorology Agency, 5 plus, 5 plus, 5 plus. So we can see the relationship among them. And then in this area is a medium. This is 5 minus, 5 minus, 5 minus. And then conclusion, according to micro-tremor observation, Padang is underlined by subsoil condition. When the VS 30 less than 400, constant result considering the soil condition were found based on preliminary observation and the questions and the questionnaire survey. In both cases, the coastal area was determined with subsoil condition less than 400 for silt velocity 300 and longer predominant period and greater seismic intensity. This is very important result, and then this important result, and then we can use it as a seismic microzonation. And then Padang has take a look at layer coastal area with predominant period between 2 and 4.2 seconds. The Tilto Mountain, this one from Micro-tremor area observation, and also from Micro-tremor observation. The subsurface geology also changed slowly from soft soil in coastal area to rocky condition in the mountain. The seismic intensity decreased from the coastal area 5 plus to mountain 5 minus. So in area 1, area 1 is here. The duration of sitting greater than 2 minutes, about 96%. So this is based on the question survey, what they feel, what the people feel when the earthquake was occurring on that time. And therefore, the result provide critical information for making shaking map, updating hazard map, and developing disaster prevention countermeasure in Padang. Thank you very much. Terima kasih kita bisa berbagi ilmu. Terima kasih, Prof. Okay, Prof. I just finished my presentation.
Okay, terima kasih, Prof. Dr. Rusnardi.
Yes, Prof.
Okay, all right. Okay, so is there any question from the floor? Ada soalan? Any question? Ada soalan. Okay, so if you don't have any question, okay, I have one question. Prof. Associate Professor Rusnardi, how do you actually develop fragility curve based on the visual observation that observed at site during Padang earthquake? Do you have done that one fragility curve for that Padang?
Yes. One week before the earthquake occurred, we were in Padang with my professor, and then when we arrived in Japan and we got information the earthquake occurred in Padang, and then we JICA team, including me, went to Padang and stay for 10 days. We do observation in Padang. We have many damage data, and also some figures, and also photos about the damage condition due to the earthquake. But Prof, you mean the fragile data or what data, Prof?
Huh?
So maybe you maybe Prof can repeat it. I mean.
Okay, the fragility curve actually that's actually want to know what is the overall damages for the estimated overall damages based on different PGA. Maybe later on we can actually collaborate doing this one, yeah, because that's good for our research in the future, inshallah. Okay. All right. So, is there any question from the floor? Okay, so if you don't have any question, can we just show your face because we want to take photo. Dr. Anis, can you snap the photo? Okay, Prof. Okay. Open your, okay, good. Video. Okay, I'm going to snap the first one. Yes, one. Wait, next. Okay, okay. Few more seconds, wait. 53 participants, okay. Right. Okay, I think that's all. Okay. Okay, before you leave, you can fill in the Google form to get your e-certificate and your attendance. Okay, so with that, I thank you very much for your participation. So we hope to collaborate with Associate Dr. Rusnardi in the future, inshallah. Okay, thank you very much for your presentation. Your very fruitful and interesting presentation.
Thank you, bro.
Thank you very much. Okay.
You're welcome, bro.
Hope to see you in the future. Inshallah, we will go and visit Padang after the COVID.
I mean, and then, Prof, if student interesting to study more about micro-tremor and then some analysis in ground motion, ground structure, we can share about that.
Okay. All right. Okay. Thank you, everybody. So hope to see you in the next series, inshallah. Okay. Thank you. Bye bye. Okay. Assalamualaikum warahmatullahi taala wabarakatuh. Okay.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam.